Well, non-stoichiometric cuprous oxide can be prepared in lab. Okay, in this oxide, copper to oxygen ratio is slightly less than 2:1. Now, instead of Cu2O, you have Cu2 minus XO. Okay, but X is very small. Can you account for the fact that this substance is a p-type semiconductor? Wow. Can we say why it is a p-type semiconductor? I guess we can. How? Let's listen. I hope you're aware that copper can exist as +1 as well as +2. Now, if the formula is Cu2O, it means that copper is +1 and oxygen is always -2 anyways. If copper is exclusively +1, the formula is Cu2O. There is also another valency of copper. Copper may also exist in +2 state. And if copper exists in +2 state, my dears, in that case, it would be CuO. That would be the formula of copper oxide. So if you have a number which is slightly less than 2 here, do you know what that means? Yes. What that means is, just imagine like this. Had I had Cu2O, but the O is always 1 here. If there are 2 coppers, it means copper is only +1. If this number becomes less than 2, if it becomes equal to 1, then it means that there is only copper +2 here. So if this number decreases from 2 and it moves towards 1, it means that in addition to copper +1, I am also having some amount of copper +2. Some amount of copper +2. So if I have a little less than 2 as a number here, that means it contains copper +1, but it also contains a little amount of copper +2. Wow. And my dears, just imagine if I have copper +1, copper +1, copper +1, everywhere I have copper +1, copper +1, +1, +1, +1, +1, +1 like this. What are you doing? I'm just telling you, just imagine the crystal lattice of Cu2O. I have copper, I have oxide, I have copper, I have oxide, I have copper, whatever. I have some such stupidity going on. Fine, whatever. And suddenly, I discover that instead of +1, there is a mole. I mean, not in the sense of mole concept, but there is an anomaly, what I mean to say. I have +2 here. Oh my God. Now what? If I have +2, do you see, if copper +1 loses an electron, it can form +2. And if copper +2 gains an electron, it can form copper +1. Yes? What do you mean? I mean to say that what is going to happen, my dears, is this, that as an electron jumps from copper +2, from +1 to +2, suddenly you discover whatever was +1 now changes to +2, and whatever was +2 now changes to +1. So before the jump, there was one Cu2 plus and one Cu plus. Even after the jump, there will be one Cu plus and one Cu2 plus, but their positions are exchanged. So it would move as if a charge has traveled. An electron has jumped in this side, so it's something like positive charge has traveled in this direction. One more electron can again jump. Again, one more can again jump. More can again jump. So electrons will jump in one direction. Yes. And they seem to be traveling towards an area of electron deficiency. Yes. It's something like we had holes. Yes. So we can account for the fact that this substance is a p-type semiconductor because presence of copper +2 cations function as, or it serves as, holes which attract the electrons from copper +1, and as these electrons from copper +1 jump in the direction of copper +2, it creates a very weak current of semiconductor or a p-type semiconductor.